Hey guys, so today we're going to do section 8.4 applications of quadratic equations, so some word problems here. On Monday we did section 8.3 where we solved quadratic equations in quadratic form. So today we are going to use the skill that we reviewed at the end of Monday's lesson, where we have rational equations that we're solving for. So take a minute and read this word problem and think about what your variable is going to be and what you are solving for. Alright, so we are solving for the time required for the new pump working alone. So that is going to be our variable that we use in our equation. Remember, rate of work, so how long it takes to do by itself, will be in the denominator. Time worked is the numerator, and then multiplied together is part completed for each pump. So the new pump rate is R, so rate for the new pump here is 1 over R. The older pump takes 6 hours longer, so that is going to be, if it's 6 hours longer, it will be R plus 6. Time worked, working together, 4 hours. So multiply each of these by 4. So the part completed for each is 4 over R plus 6 for the old pump, and the new pump is 4 over R. Them working together, they're emptying one pool. So you are writing each of their parts completed, adding them together, and setting it equal to 1. The equation will look like this. Remembering how to solve this equation, to get rid of your denominators, you need to multiply the whole equation by least common multiple. R and R plus 6 do not have anything in common, so we're multiplying our equation by both R and R plus 6. So go ahead and multiply that out. Alright, multiply that out. That's what this looks like here. R plus 6 cancels in your first term, so 4 times R. The second one here, R cancels, and you're left with R plus 6, and you have to remember you're distributing the 4 for each of these. 1 does not have a denominator, so he needs both of those factors there. Alright, distributing the 4 and the R, go ahead and simplify this equation. Alright, that's what it looks like there. Our R squared term, we have a quadratic equation here. R squared is positive on the right, so I'm going to move over the 8R and the 24. So R squared minus 2R minus 24. Factoring that, R minus 6, R plus 4. Running out of room, going to write over here. So R equals 6, R equals negative 4. We're not dealing with negative time, that one doesn't make sense. So R equals 6. Looking back up here, R plus 6 and R, both denominators would be fine. So our question was, find the time of the new pump working alone, and that is R. So our answer would be, it takes 6 hours working alone for the new pump. So that is our answer. It takes the new pump 6 hours working alone. They didn't ask anything about the old pump, so don't waste any time solving that out. Alright, next word problem. Take a minute and read this. Alright, so you have a jet. That speed is 225 if there is just calm air. We have wind going with and going against. So we're looking for the rate of the wind, so that's our variable that we're going to be using. So W is the rate of the wind. If you are flying with the wind, and you are currently going 225 miles per hour, and then you're going with the wind, it's helping you out. So if your wind, say, is 5 miles per hour, your speed would increase by 5. So you're adding when you're with the wind, and you're subtracting when you're against the wind. The distances are the same here. You are flying 1,000 miles with and 1,000 miles against. They make a relationship versus the time. So we're actually using the equation distance equals rate times time. Since our relationship is dealing with time, when we solve this equation for time, time equals distance divided by rate. So we're going to make up a chart with and against the wind. Alright, so setting that up. With the wind. With the wind, your rate is 225 plus the wind, and against the wind is 225, and then it's harder to fly, so minus W. The distance is the same for both, 1,000 and time is distance divided by rate. So we are dividing each of these and setting them as fractions. Alright, so there's our two fractions here. The time it takes traveling with the wind for the 1,000 miles and the time it takes against the wind. Now, they say here flying with the wind takes 1 hour less time. So if we're setting these two equal, we have to balance out that equation. So with the wind and against the wind, if it takes 1 hour less time with the wind, so if it takes with the wind 5 hours, then against the wind it would take 6. So we have to add the 1 hour that's extra for with the wind so that they would be equal. You could have also done against the wind and subtract 1. I always like to deal with +1 just so that you don't have to deal with distributing a -1 when we multiply out the least common denominator. So getting rid of our two denominators here, they are same numbers, they are the same terms, but one's plus and one's minus. We have to multiply everything by both. 225 plus W and 225 minus W. So go ahead and multiply that out. Alright, multiplying the LCD to everything here. This is what we have. We have to distribute and simplify this equation, so go ahead and take a moment, hit pause and do that. The 1,000s and also this piece here is difference of squares, so our 225W's cancel out. One's positive, one's negative. Looking here, we have a quadratic equation with this W squared here. So we're going to move everything to the right. Notice both sides have a positive 225,000. So when we move this guy over to the right, they actually cancel out. Be careful. The same does not hold true for the 1,000s. This is negative 1,000, so when we move it over to here, we're adding 1,000 to the already 1,000W. So we have 0 equals W squared plus 2,000 minus that 50,625. In this chapter, we've learned 3 different ways of solving quadratic equations. Oops, I forgot a W here. We've learned 3 ways of solving quadratic equations. Try to factor it if it's factorable first. If not, completing the square or quadratic formula. I always use quadratic formula over completing the square. This equation is factorable, so I'm going to show you the factorable way of solving this equation. However, if you get stuck when trying to do this word problem and you can't figure out how to factor it, always revert back to doing the quadratic equation. Just be careful since 2,000 and 5625 are both very big numbers. Alright, so factoring this would be W minus 25 and W plus 2025. Solving this one would result in W equaling a negative number, so that is not correct. This one here, W equals 25. Looking back up here, they said W was the rate of the wind, and that's what we're looking for. So the rate of the wind is 25 miles per hour. So that would be your answer to question number 2. Number 3. The length of a rectangle is 2 feet less than 3 times the width, and the area of that rectangle is 60 feet squared. Find the length of the rectangle. We have done this type of problem before, so we need to connect what the length of the rectangle and the width of the rectangle are and use our area formula since that's what they gave us. So let W be your width of your rectangle because the length is written in terms of the width. So 2 feet less than 3 times the width. So the width is W, so 2 feet less than 3 times the width would be what? That would be 3W minus 2 for the length. If you want to, in your notes, you can write L equals 3W minus 2. Area for a rectangle, area equals length times width. So we're going to fill in all the information we know. We're keeping W, but length is 3W minus 2, and they give us the area is 60 feet squared. And this is a quadratic equation that we're going to solve. So go ahead and distribute the W. You are allowed to do it this way. Multiplication is commutative. So 60 equals 3W squared minus 2W. The 3W squared is positive on the right, so we're going to move the 60 over. Go ahead and take a few minutes and factor out this quadratic here. Remember, be careful, our squared term has a coefficient other than 1. So go ahead and take a few minutes and factor out 3W squared minus 2W minus 60. Alright, factoring that, we're looking for two numbers that multiply to get negative 180, and their difference is 2. So that would be 18 and 10. 18 needing to be negative. Sorry, 18 and 10. Scratch that. That was not correct, because 18 and 10, their difference is 8, not 2. My bad. Going through. This, unfortunately, is not factorable. So let's go through the process of doing the quadratic formula. So, quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. Plugging that in, go ahead and plug that into the quadratic formula using a is 3, b is negative 2, and c is negative 60. Alright, so negative b is negative 2, so positive 2, negative 2 squared is positive 4, minus all of this. Multiplying this out here, you get 4 plus 720, 2 plus or minus all over 6. 6 came from 2 times 3. So this here, 2 plus or minus the square root of 724 all over 6. 724, the square root of that is definitely bigger than 2. So these two answers, 2 minus the square root of 724 would be a negative number, so 2 plus. So we can get rid of the answer that has the negative. So 2 plus the square root of 724 all over 6. Yuck, that is not a nice answer, but that is what it is there. Alright, that is the width of the rectangle. So the length of the rectangle, you'd multiply that out. In this instance, it's such a crazy number here. We're multiplying that by 3 and then subtracting 2. So this is W. So multiplying that out by 3. 3 times that number, since 3W minus 2 is your length. 2 plus that square root. Minus 2. Yuck. Oh, before we do that, 724, 4 goes into 724. So the square root of 724 is 4 times 181. So that is actually going to be 2 plus or minus 2 root 181 over 6. So the 2's and 6 have a common factor of 2. So this is actually the final answer of this would be 181 over 3. So we're only taking the positive one of it, not the negative one, because we don't want the negative answer. So multiplying that by 3 and subtracting 2 makes it a little bit better since 3's cancel. So 1 plus root 181 minus 2. Your final answer would be the square root of 181 minus 1. That would be the exact answer. The estimate is approximately 12.45 feet. Alright, so you're seeing how ugly it can be with not coming out nicely.